Hello, myself Anushri Dhole. In this video, we are discussing the topic Bain Bridge mass spectrograph. The principle of Bain Bridge mass spectrograph is it is a device that detects the isotope of positive particle and determine the mass of the isotope from known mass. Isotopes. The element are having same atomic number but different mass number is known as isotope. Construction of Bain Bridge mass. The brain beach mass spectrograph has three important parts. First, source of isotopes, ion source. Second, velocity selector and analyzing chamber. Diagram of Bain Bridge mass spectrograph. A discharge tube produces positive ions of the element under investigation. The slit S1 and S2 collimate the incoming ion beam. The ion beam passes through a velocity selector. Beyond velocity selector, another slit S3 is arranged, which further collimates the monovelocity beam. Photographic plate is mounted in the analyzing chamber in line with the slit S3. Working. The element under study is taken in the form of gas and introduced into a gas discharge tube. Isotopes are being ionized to singly charged ion with the help of gas discharge tube. Generally, these ions are positively charged ion. These ions are accelerated and further collimated toward velocity selector using slit S1 and S2. When these isotopes pass through the region of velocity selector passes only those isotopes whose velocity is v equals to E by B, where E is electric field intensity and B is magnetic flux density. After passing through slit S3, isotopes enter in analyzing chamber, where transverse magnetic field is present and represented by a cross sign. Because of transverse magnetic field, isotopes experience magnetic force and hence isotopes describe semicircular path and register a line on a photographic plate. As magnetic force equals to centripetal force, then we can say that QVB sine theta equals to mv square by r, where q is charge of particle, v is velocity of particle, m is mass of particle, and r is the radius of semicircular path. Then r equals to mv by qb. Then we can say that m, which is mass of particle, equals to qbr upon v. When we substitute v equals to E by B in equation first, we get m equals to q b square r upon E. Let's consider x is the diameter of some semicircular path. Then equation 1 becomes m equals to q b square x by 2e. That is m equals to kx, where k is a constant and the value of k is q b square upon 2e. From the above equations, we can say that Bain Bridge mass spectrograph has a linear mass scale. From the equation 2 and 3, it is also stated that ions isotope with different masses trace semicircular path for different radii and produce dark lines on the photographic plate. All the particles having the same mass are focused on a single point of photographic plate. The intensity of a line on photographic plate is a measure of the abundance of isotope. If M1 and M2 be the mass of two isotopes and X1 and X2 are the diameters of semicircular path, then we can say that M1 becomes cube b square x1 upon 2e and M2 becomes q b square x2 upon 2e. The difference between two lines of photographic plate is change in diameter equals to x2 minus x1. So we can say that delta x equals to 2e upon qb square multiplied by m2 minus m1, that is difference between masses of that isotope. Thank you.